On this video, we will be discussing about the different theorems related to circle, and the first one is the theorems related to chords itself. So first one is theorems related to chords. Theorems related to chords. Related to chords. Okay. Now first one, let's say I'm having a small circle like this, and I'm having the center at here at O, and I'm having a chord also here, and I'm having a chord like this, and then I'm going to draw a straight line from the center to the chord with an angle making 90 degrees. In that case, then this particular line is bisecting the chord AB. And let's say the point where it is touching the chord being N, then I can say that AN is equal to NB. This point is bisecting AB at its center. And as a definition, we can say that the perpendicular bisector of a chord of a circle passes through the center. That is the first one. Now moving on to the next one. Now here I'm having another circle, and let's say I'm having two chords in this case. And this being my first chord, this being my second chord, and I'm having the center here at O, and let's say this chord is AB and this chord is CD, and they are of the same length. That is, AB is same as DC, and the chord AB is forming a angle at the center like this, and the chord DC is also forming a line, forming an angle at the center like this. So I'm having two angles here, this angle and this angle. And if two chords of same length is forming an angle at the center, then those two angles will be the same. That is the second theorem. That will be angle BOA is equal to angle DOC. And as a definition, we can say that equal chords subtend an equal angle at the center part. That's all about the second one. Now moving on to the third one. And here also I'm having a circle like this. I'm having the center at the point O, and in this case also I'm having two equal chords like this, and I'm naming it as AB and CD itself, AB and CD. And the next thing, I'm going to draw a perpendicular line from the center to one of its chord, and here also from the center to one of its chord, making an angle 90 degrees. If I'm having two chords of equal length, that is AB equal to CD, the distance of the chord from the center will be same in this case if I'm having two equal chords. So that means if I'm naming this as N and this as P, then I can say that the side or the line ON is same as OP. So as a definition, I can say that two equal chords of the circle are equidistant from the center of the circle itself. That is all about the third theorem. Now we will move on to the theorems related to arc and some angles. Let's say I'm having a circle like this, and I'm having 2 points here. The first point being A, and second point being B. So, and let's say I'm having a small x here also. So what I'm going to do is that I'm going to make an angle by using this arc AXB, or AB itself. Now what I'm going to do is that I'm going to make an angle by using this arc AXB. So that means AXB is making an angle like this, and let's say it is at the point P. So this is my arc and that is forming an angle, and the same arc itself is forming another angle right here, and that would be what? That would be exactly here, and that angle being N. So I'm having an angle here and I'm having an angle here. So I want you to visualize this one. This is my arc and this arc is forming an angle here, and this exact same arc is forming another angle at the point N. And if that is the case, if the same arc is forming two angles or more than two angles itself in the at any point in the circle itself, then the angle APB would be same as angle ANB, and that is my first rule. And as a definition, I can say that the angle subtended by an arc at any point on the remaining part of the circle would be same. That means I cannot form any angle in this particular arc itself. I have to be, or the angle be, on the remaining part of the circle itself, and that will give me the first theorem. Now moving on to the next one. Let's say I'm having a circle like this, and the center of the circle is at the point O, and like the same case, I'm having an arc here, and with the names as A, X, P. And what I'm going to do is that I'm going to form two angles, one angle being drawn from the arc at the center of the circle, and another one being drawn in any of the other part of the circle. If that is the case, and I'm assuming this point as P, and this angle I'm naming it as theta, then this particular angle that is formed at the center of the circle will be double that angle. That will be 2 theta. So as a definition, I can say that angle AOB is equal to 2 times the angle APB. So as a definition, I can say that the angle formed by the arc at the center is double the angle that is formed by the exact same arc in any other remaining part of the circle itself. And I wanted to visualize this part. This is my arc, and this arc is forming this 2 theta angle. This exact same arc is forming this theta angle itself. And that's all about the second theorem. Now we will move on to the next one. The next theorem is related to a cyclic quadrilateral. Cyclic quadrilateral means a quadrilateral that is being placed inside the circle itself, touching the points on the circle itself. So we will have a circle. So let's say this is my circle part, and I'm having the center at O, and I'm having a quadrilateral inside it. So I'm having a quadrilateral like this, and I'm naming it as A, B, C, D. If this is the case, then the opposite angles are going to be supplementary. Supplementary means the sum of the angles will be equal to 180 degree. That means the angle A plus the angle opposite to A is angle C. Angle C is going to be 180 degree, and the angle B and D is going to be 180 degree. So angle B plus angle D is going to be 180 degree as well. So that is my first rule. The opposite angles of a cyclic quadrilateral will be supplementary or will be 180 degree. Now moving on to the next one. And for this case, I'm having a circle part, and this is not related to a cyclic quadrilateral. This is more related to a triangle itself. And I'm having a point O here, and that is the center itself. And I'm going to form a triangle in such a way that one of the side is going through the center of the circle and touching the other side of the circle itself, or one of the sides of the triangle is the diameter of the circle itself. And if that is the case, then the other side that is formed on one of the points on the circle itself will be 90 degree. So that is my second rule. Now as a definition, I can say that if I'm having a triangle with one of its side as a diameter and the third angle is present on the circle itself, then the third angle is going to be 90 degree there. So that's all about the second rule. Now moving on to the next one, that is all related to the tangents of a circle. So the tangent theorems, and first we will consider a circle itself and we will see what do you mean by a tangent first of all. So I'm having a circle like this. A tangent is nothing but a straight line that is passing through one of the point on the circle itself. And through that point, I can draw only one tangent. For example, I can say that this being one of my tangent. And through that particular point, I can draw only one tangent. If that is the case, and I'm having the center at the point O, and I'm drawing a straight line to that point itself or to that tangent itself, then the angle is going to be 90 degree there. That is my first rule. So as a definition, I can say that the tangent of a circle is perpendicular to the radius of the circle at the point of contact itself. Now moving on to the second one. So here also I'm having a circle like this. And I'm having the center at this point O, and I'm having an external point right over here. So what I'm going to do is that I'm going to draw two tangents from this point to the circle itself. So the first one will be this line, and second tangent will be going on like this, and it is touching one of the point in the circle itself. Okay, and I'm drawing the radius also here, and here the radius is going to be 90 degree as per the first rule, and here also the radius is going to be 90 degree. And I'm noting this point as A and this point as B, the point where the tangent is going through. If this is the case, that means two tangents drawn from an external point C passing through the point AB on the circle, then the line AC and BC will be of the same length. That means the side AC will be equal to the side BC. That is the second rule of the tangent theorem. So as a definition, I can say that two tangents drawn from an external point will be of the same length. So that's all about the theorems related to circle. On the next video, we will be discussing about the different shapes I'm going to get by repeating the same circle, like the cylinder, like the sphere, the volume, surface areas related to all those figures we will be discussing on the next video. So see you there. Take care. Bye.